Hello, everyone. Thank you very much for joining our award ceremony. I am currently unable to see. Okay, that's where it went. See all of you. Okay, good. Thank you very much for joining. So today is the day that we're going to announce the winning teams of the OrbitalAI Challenge. Some of you may have joined already back in February, so it's been a long challenge and a lot of hard work from your side. So really excited to see what came out of it and what you have all done. So without further ado, we're going to just start with giving you a short overview of the challenges that you've been working on, the missions that your algorithm might be launched on, so VSAT-2 and Imagine. We're going to quickly remind you of what prizes you can win with this challenge, and then we'll have the official announcement of which teams will continue to the incubation phase and some more information about that incubation phase afterwards. Well, happy to have you all here, and I'm going to pass the floor on to Nicola Melega from the European Space Agency to discuss the VSAT-2 mission.
Yeah, thanks. I'll try to be as quick as I can.
Catherine, maybe just a quick note. We don't see the full screen. Yeah.
Okay.
Thanks.
Let me just. Then I'm going to. This better?
Yeah. Yes. Can you move to the next slide, please? Thanks. So, as I was saying, I'm pretty sure that the VSAT-2 mission has been already presented before, but just to remind what are we supposed to do? As every mission, we have a series of objectives. In this case, first of all, is to demonstrate the enabling capabilities of running multiple onboard AI applications. We are going to do it by using them in a standalone way. We are going to try to chain multiple application on boards. We are going to test, update, and upgrade services. So there is a whole lot of things that we are planning on do with these applications once the mission is flying. But most of all, one of the main objectives we have is to demonstrate the relevance of using AI application on board for operational missions. So the aim here is to demonstrate the viability of running this application on board, targeting in a not so distant future the same thing on operational missions. So how are we going to do that? Well, as a starter, with a very small mission. So we designed and, to this date, manufactured a small 6U CubeSat, which is equipped with a multispectral camera, which is the payload that has been selected for this mission. This multispectral camera has 8 bands, provides roughly a 5-meter GSD from our orbital altitude, which is around 500 kilometers. And then the mission is equipped with a combination of payload processors. So one is a payload preprocessor that can provide the equivalent of level 1B data on board. And the other one is the actual AI hardware accelerator that will be used by the various applications. If you can go to the next slide, please. So what are we going to do exactly? Well, first of all, we are going to acquire data according to the requirements specified by the various application providers. As many of you already know, we have 4 applications already selected for onboard operations, cloud detection, SAT2MAP, the autonomous vessel awareness, and the deep compression application. As you can see on the right side, the satellite is almost completed. And the plan is to launch the mission between the end of Q1 24 and the beginning of Q2, and to start nominal operation at the end of Q3 of 2024. And this is a very brief summary of the FISA-2 mission.
Thank you very much, Nicola.
You're welcome.
We also had, of course, Microsoft and Thales Alenia so working together with us on this challenge, and they have the Imagine space mission on board the ISS. So Elisa, can you give us a bit more information about that?
Okay, sure. So I'd like to say first, good morning, afternoon, or good night to whoever is connected right now. To all the innovators and space lovers, I'm very happy to be here today and recognize the work performed by several incredible teams. And if we move to the next slide, just to remind the operational concept and the design behind the Imagine mission. That's in collaboration with Microsoft. We are developing an experiment which is centered in a space computer, and that will be deployed on board the International Space Station. And it will allow us to gather and match Earth observation insights. We are going to be launching a high-performance computer from Thales in Spain, plus or integrating an in-orbit application framework from Microsoft. And we will this payload will be also including 2 state-of-the-art sensors on the ISS. These 2 sensors available are an hyperspectral and an optical one. That is the ones that our participants are used to propose their ideas. The package provides a fantastic opportunity to demonstrate and validate the potential of cognitive cloud computing in space. And that's what we have tried to push forward with this challenge. This next slide. And we will launch this space computer payload to the ISS, where a robotic arm will install it on the outside of the Columbus module in a platform which is specifically designed to make experiments in a space environment. And this is a main difference with other space computing experiments performed in the past on the ISS because they were in a controlled environment. But today we are on the outside of this module. This payload is intended to be in operation for 1 year, and it has a great potential to change the paradigm of space resource use. And all the teams that have participated to the challenge has proposed different applications that demonstrate this concept. So this mission was intended not just as a technological demonstrator, but as a market one. So thank you to all the participants that are contributing to democratize the access to space and to these first stages to integrate the terrestrial cloud within the space, because these applications will be able to deploy on the ISS on this space computing module simultaneously, and we would be able to update these applications at any time during the mission lifetime. So thank you.
Thank you very much, Elisa. So those are the 2 missions that all of you worked hard to get your own algorithm on board of them. So if you are successful, of course, the big prize is that you can take part in the incubation phase, helping you refine your algorithm, and the top 2 of each incubation phase of each track then actually have the chance to launch their algorithm on board one of these 2 missions. So it's super exciting. But to all of the participants here that have managed to go into the incubation phase, that have provided a prototype and a pitch that was really, really good, and that passed through our jury at ESA, at Microsoft, at Thales Alenia, you will also have the possibility to choose from a prize pool. So regardless of what happens later in the incubation phase, there's a whole prize pool from which you can pick 1 to 2 things, and or 1 prize per team, and then you will have the chance to either go to the ESA Phi Lab at Esrin for 3 months as a visiting researcher, work on more of your work in AI, in Earth observation, be at the forefront of developments in the Earth observation sector, be surrounded by really smart people working on the same things, and really be inspired in a very nice environment in Esrin in Italy. Then we also have prizes by Synergize. They are offering 10 subscriptions to Sentinel Hub, as well as some Sentinel Hub goodies. NV5, previously L3Harris, is offering training and access to licenses for NV and IDL. And then there will also be a peer-reviewed journal in JSTARS, a special publication, a special issue whereby we will cover for the teams interested the publication fee. But to go a little bit deeper into those different prizes that you can get now already, the European Space Agency managed to get a special issue in onboard intelligence for Earth observation and planetary exploration. So an ideal topic for this challenge. So up to 5 people can, or 5 teams can get their publication into this journal. The deadline has been extended till the end of 2023, so you still have time to work on a paper to submit. So if this is one of the things that you're interested in, don't hesitate to start coming up with the paper and how you're going to put it forward. Then we also have Sentinel Hub licenses.
Hi there. In this video, we present Sentinel Hub technical capabilities. Sentinel Hub is a cloud-based GIS service which brings satellite imagery data seamlessly in desktop and online GIS applications. To explain its inner workings, let us provide an example on Sentinel-2 data. Our archive infrastructure downloads worldwide data from the Copernicus Scientific Data Hub, performs automatic processing, and makes the data available through browser GIS interface or through OGC compliant services or APIs, which can be easily integrated in third-party applications. So far, there are more than 50 terabyte data stored in the cloud, adding more than 1 terabyte every day. Usually, the data are available within an hour from when they are distributed by European Space Agency. Let's see how data can be accessed via our web-based GIS engine, Geopedia. Start by browsing.
So you might already know the Sentinel Hub from the interface, but Sentinel Hub also has this whole cloud infrastructure in the back whereby you can access and process satellite imagery. So there will be up to 10 basic subscriptions to be given away. And then we will also have an NV and IDL licenses and training. But for that, we also have Joey from NV5 here. So perhaps you can give a little bit more information about what that entails.
Yeah, absolutely. First off, I want to congratulate the winners and all the participating teams, as well as thank the organizing committee. So the prizes that they kind of talked about there would give you access to NV and IDL. And for those who are not familiar with NV, ENVI's been around for about 30 years, and it was largely built on being able to process hyperspectral and multispectral data. And as of late, as the use of deep learning and machine learning has continued to come up in our industry, we've built in tools within ENVI to give you access to using machine learning or deep learning and help you not have to take it the step of having to code to bring in different data formats. So a lot of that's just file open in ENVI. So kind of take that part of the process out and let you focus on creating, really powerful models and classifications. And we can also send out a link on what ENVI is as well. But we'd like to invite the 10 selected participants the opportunity to use ENVI for the next 6 months and be able to use that to help support your work, as well as participate in the online trainings and kind of get your feet under you on how you can use ENVI for different applications. For the training, you can reach out to the organizer and they can help set that up from there. And then the 2 final winners will also have the option to receive a 1-year ENVI term license if they want. And really that gives you access to ENVI for an entire year, including machine learning. So thanks again to everybody who participated, and congratulations to the winners. And we're excited to be a part of this.
Thank you, Joey. So I think that concludes the prizes. Oh yeah, the prizes for the winning teams. But I'm sure that might be already things that you already knew. So without further ado, we want to announce who are the 10 winning teams who are the winning teams for each of the 2 tracks. So the jury has been working hard, looking at your pitches, looking at your prototypes, and they've selected the best teams that are compliant as well, and to be able to continue in the incubation phase. So I don't know if we have. Okay. So we will start with the FISAT 2 challenge. And Nicolas Longepé, who is running the AI for AO challenges at ESA, will announce the very first winner.
Yeah, very glad to announce that today. Obviously, it has been a very long journey to arrive at this point today. So the first one that will be selected for the incubation phase will be the team from Grenoble. So it's a team composed of scientists and researchers from different universities and institutes in Grenoble. We have GIPSA Labs, data science experts, the Grenoble University Space Center as well, and the Grenoble Institute of Technology. So they are all based in the city of Grenoble in France. So maybe we'll take this occasion to welcome you on the stage. I mean, I don't know if you can show up, open your webcam and mic and say some few words about yourself, maybe also describe in like 30 seconds your solution. Is that feasible, Catherine?
Or if you quickly raise your hand, I can allow you to speak.
Yeah, I could see Jocelyn
Wait.
raising his hand, and also Tanya.
Oh.
You can say like in 30 seconds, describe who you are and what you proposed. It would be fantastic. Over to you.
Okay, Tanya, do you want to start?
Hello, everyone.
That's a nice start.
We're already
Okay. Hello, everyone. Can you hear me?
Yeah, perfectly.
Okay.
Go ahead.
I'm named Tanya McNamara. I work in the Grenoble Space Center in the University of Grenoble. And I'm a project manager of a similar CubeSat to FISAT called CleverSat since 2020, so the last 3 years. We're working on a different hardware, but similar software, and not just clouds, but all sorts of textures visible from the low Earth orbit. Okay, that's it for me.
Thank you. Jocelyn, do you like to complete a little bit the message? What did you submit it? What's your offer?
So My name is Jocelyn Chanusso. I'm working in academia as a research director at INRIA. And this work was done in collaboration with a team in Cepsa Lab and with engineers at Data Science Experts, DSC, which is a startup based in Grenoble. And I don't know if Paul and Noé are here. I know Loic is there online.
Yes.
So the goal is to provide a solution that can perform texture detection and pixel-based classification for a multitude of applications. And we can perform both inference and training on board, meaning that you may want to detect deforestation areas. You train your network on board just by sending a few spatial coordinates. And then the next day you want to change the application to the detection of clouds or whatever. Again, you can update you can perform the training on board and change the topic of your algorithm. And the proof of concept was already validated using a space-qualified processor called Cormino, provided by Teledyne E2V.
Okay, great. Thank you very much. And welcome on board.
Yeah, thank you.
Thank you very much.
Congratulations, Grenoble. Next up, and just to clarify, this is in no particular order. So the 10 teams or the teams that have been selected are all equally stepping into this incubation phase. So, but the next team is Telepix and Kiosk. I'm not sure if I pronounced that correctly, but they are a combined team of the Korea Institute of Ocean Science and Technology and the Telepix Imaging Science Research Team, which are both based in South Korea. So I hope we have people from either Telepix or the Korea Institute of Ocean Science and Technology online. If so, quickly raise your hand, because I would love to hear a few words from you about what it is that you've done. I thought I saw someone earlier.
It might be late for them as well.
Yes, yeah. Okay, well then already congratulations, Telepix and Kiosk. You will hear more from us afterwards then.
And the next one is actually a team from Netherlands, and a team composed by researchers working at the Royal Netherlands Aerospace Center, which is AMRR, AI for EO. So I don't know if you have some guys from that team in the call. If you would like to say some few words, it's your moment. You can shine. Yes, we have Job De Vries willing to speak.
Can you hear me?
Yeah, we do. Go ahead.
Well, thank you very much. I'm representing the team from the Netherlands, indeed, at NLR. We're a research institute at the space industry. And we submitted an ID to work on onboard state change detection. So we developed a combination of algorithms where we can define a process of interest that we would monitor over time, and then do the onboard change detection simultaneously. That's roughly in a nutshell the idea that we came up with.
Seems promising. Okay, thanks a lot.
No worries.
And welcome up.
Thank you very much.
Next up is a team that we are already quite familiar with, because they're very active in the AI for EO community. TCSA AI, or Tracasa. And I see we have Christian Ayala on the call. Christian, do you want to say a few words? Oh. If not now, then already welcome on board, Christian and your whole team at Tracasa. Great to see you back in the AI for AO challenges, and welcome aboard the onboarding phase.
And actually, the next one is not a European team. It's a team coming from India, Bangalore, which is actually SkySurf, and this is a startup that's aimed to provide an insight as a service platform, enable satellite-based edge compute insight. So welcome on board. So I don't know if you are nearby, if you can say some few words about your solution, that would be great. I don't know what time is it in India now, but it's your moment. Yeah.
Hey, hi.
Yeah, hi. Good
This is
evening.
Aditya. So I'm from SkyServe, but the actual team that worked on this was not able to join. But thanks for the opportunity to participate. And our solution was essentially a continuous monitoring of road health. So transportation is a key necessity for all sorts of like daily activities, commerce, pushing the economy forward. So that's basically a solution to continuously update trafficable roads by giving their conditions on an almost real-time basis to all providers who can integrate this into their navigation solutions.
Okay, sounds great.
Thank you.
And next up, we're heading back into Europe because the next team is OHB Hellas, naturally based in Greece and part of the OHB group, a group of companies that have been working for a long time in the space industry, building satellites, but very happy to see that you are also now making algorithms for onboard processing. Is there anyone from the OHB Hellas team online that wants to? There you go. Evgenios?
Hi, can you hear me?
Yes.
Okay, thank you. Thank you. Congratulations to the fellow winners. Thank you to the organizers, ISA and Philab. As you said, yeah, we are a team from OHB Hellas, another company of OHB in Greece. We are a team of 4 people, a senior space expert, Mathieu Bernou, 2 machine learning engineers, myself and Panagiotis Dorotitis, and an embedded engineer, Adonis Karteris. Our goal was to enable faster near real-time downlink transmission through onboard content-aware compression. So essentially, our model compresses images based on how useful the image content is. And this is especially pertinent for us in Greece because of, you might have heard, like recent wildfires and floods that led us to develop this model in hopes to improve near real-time decision-making. So thank you again. And we hope to have a great collaboration moving forward.
Definitely, looking forward to that. The next one, which is selected for the onboarding phase, is a company based in Oxford and Houston. They have been founded in 2020. And this is Little Place Labs. I think they are in the business of making satellites and spacecraft smarter with AI on board and machine learning. So I don't know if you're in the room, willing to speak and say something about yourself and your solution. Are you there? Okay, it seems that nobody in the team. I see.
Hi.
Puneet? Yeah, go ahead.
Yeah, I hope you guys can hear me.
Yeah, we do. Go ahead.
Yeah, so I was expecting my whole team to be here, but I think most of them couldn't join. But we are very happy. Thank you very much. We worked really hard on this project. And our project is about, so what we would be doing is we would be detecting burnt areas from all over, from all the data that we get through. And once we have the burnt areas, we would be doing carbon mapping and estimating carbon loss all over the world. So we would like literally be calculating the rate at which the world would be burning up. So that's our solution. And thank you so much.
Our pleasure.
A very, very relevant application. next up, we are going to France. IRT Saint-Exupéry is a private research foundation based in France, and they have been actually the first ever to successfully run a neural network on FPGA in orbit during experiments conducted on the ESA OPSAT satellite back in 2019. So very, very cool to see that you're continuing this work now for VSAT-2. Is there anyone from Saint-Exupéry who wants to say a few words? Yes, Adrien.
Hello, can you hear us?
Yes.
Yep.
Hi. Hello to all the participants, and thank you very much for the organization. Yes, so we are a research institute, technological research institute based in France, specialized in space and aeronautics. And in the frame of the challenges, we have been proposing a solution which performs anomaly detection on board, especially focused on the maritime environment. And our solution is innovative in the sense that it is frugal, so it doesn't require a lot of data nor computing resources to run. And it also combines different types of algorithm. It's a hybrid approach that mix self-supervised neural networks and genetic algorithms. So this is what is original in our solution, I guess.
Okay, welcome on board, Adrian and team. The next one is, I mean, they are based not so far from Frascati. They are based in Rome, and those are people from Thales Alenia Space in Italy. And this is the team SAIS from Thales Italy. I see there are some, yeah, Federica. There should be some other guys in the room from Thales Italy. Federica, if you'd like to say some few words. I think that you have to unmute yourself. Okay, it seems that we have some kind of technical issue. So I would suggest that, I'm sorry for you, Federica. Welcome on board in any case. I suggest that we move to the next one and eventually come back to you guys if you can speak again. Go ahead.
And so the next one to be onboarded in the VSAT-2 onboarding phase is AI for ED of ET. It's a team composed of researchers from Delft University of Technology in the Netherlands, the University of Sanyo, and the Cosine company also as well in the Netherlands. And I believe Sylvia is here to represent them. So Sylvia, I would love to hear what is behind your name, actually. The team name.
Thank you very much. Can you hear me?
Yes.
Yeah.
First of all, thanks to all of you, because you are an awesome team, what you have done to follow all of us. So first of all, thank you. And we are all honored to be with you on board of this mission, let's say. I'm not alone. I'm with some people here from University of Sagno. Our proposal is for a near real-time detection of contaminants in coastal waters and open sea, and is a Netherlands and Italy-based team composed of a group from University of Sagno. I would like to spend just 1 minute to list the people. Francesco Mauro, Pietro Di Stasio, Francesca Razzano. And there are other 2 members from Netherlands, Gabriele Meoni from the University of Delft, and Marco Esposito, that is the co-director of the environmental space sector in Cosine, a company based in Netherlands with some headquarters also close to our university in Benevento. So this mix of teams have brought to this result. I want to thank all of them for what has been done until now.
Great. Thank you very much, Silvia.
I don't know if someone else is online because I cannot see if there are other people. I don't know if Marco is online from Netherlands.
Yeah, it seems to be.
Marco is here.
Marco, you have to raise your hand to have access to the microphone.
Yeah, I'm here. Do you hear me?
Yes.
Yeah, we do.
Very good. Yeah, no, thank you to all. So it was very nice and nice to be in this selection. So looking forward to the next. Indeed, I'm from Cosine, so very honored to be with Silvia here. That's it.
Great. Thank you very much. Just to go back to the previous team, Federica, do you want to try again? To unmute? I see you logged in again, so perhaps that helped solve the technical question, the technical issues.
Meanwhile, I like to thank all the participants to the FISA2 track. Obviously, I duly acknowledge the effort to participate to this challenge. I mean, this is way beyond the standard, let's say, Kaggle data challenge. The data quality, I mean, the quality of the different proposals that we received was very good, and we had to select only a few of them. I'm very sorry for the one that could not integrate this incubation phase. This is not the end of the collaboration, so please feel free to come back to me, comments and so on. I mean, we can further build upon your idea, even though it will not pass the next step. And for those joining, obviously, welcome on. So Federica, this is your last chance to comment or to talk. If not, I suggest that we move to the Imagine Awards.
Yes. Yeah, let's do that. So, on the Imagine side, Nicola, do you want to start?
The first team selected is also a team from Italy, from Federico Due Napoli and University of Genova. And this is the team Latitudo 40, which is a startup based in Napoli doing AI, machine learning, and big data analysis applied to Earth observation imagery. So I don't know if you're in the call. Yes, Antonio.
Can you hear me?
Yeah, we do. Go ahead.
Okay.
Thanks.
Hi, I am Antonio. I am a PhD student in artificial intelligence for environment, and I'm at Federico II of Napoli in the PICUS lab. That is a group that makes AI research, and we have a very strong collaboration with the Latitudo 40, that is a startup that has in Latitudo 40, for example, there is Giovanni. He is another PhD student of Federico II, and he is also affiliated with this startup. And there is another guy, Mattia, that he works for Latitudo 40 and is also a PhD student from University of Genova. So there is this combination of PhD students and people that works for Latitudo 40. And this is a collaboration among Federico's PICUS lab from Federico II, Latitudo 40, that is this startup that works in Earth observation in Napoli, and also University of Genova. And we worked on DraftScope, so a solution that using the hyperspectral images and using public data, we can find crop, and we can define evaporative stress index on crops. So in a way that we can define some threshold the drought on crops. don't know if can you hear me because
Yeah.
okay, and that's it.
Okay, thanks a lot, and welcome on board. The next step with us. And Catherine, would you like to move to the next one?
Yes. So next up, we are moving back to the other side of the planet with Telepix. So Telepix, mentioned before already, they are a satellite image manufacturer and an insight extractor based in South Korea, and it's the image science and artificial intelligence research team. So I see here Hagai. Are you part of the team?
Hello.
Hello.
Hello everyone. Thank you so
Hello.
much for the opportunity for both of our teams on the PSAT-2 and Imagine E-tracks. So I'm Hagai. I'm part of the AI team in here. So I'm sorry. I thought my friends were here for the PSAT track before, but it's just me. It's 11 p.m. now, almost 12 p.m. in the midnight in here. So probably my colleagues are already fall asleep because tomorrow we also have to work. But thank you so much. Thank you so much for the opportunity. We are so happy to be part of this great move in the space exploration. So
thank you very much, Hagai, for joining us so late, and welcome on board.
The next one to be selected is indeed GOF. So the same, you will have to explain maybe the acronym of GOF. This is a team from various universities in Europe, and from Torino, Montpellier in France, also Rennes and Côte d'Azur universities. The floor is yours. If you'd like to present yourself and your idea, that would be fantastic. Any people from GOF team? Okay.
Wait.
Chloe Campo, go ahead.
Hi, can y'all hear me okay?
Yeah, go ahead.
All right, well, thank you so much for choosing us in this challenge. And GOF stands for Guardians of the Floods, as we are focused on flooding hazards. And we're really excited to bring this to the next stage and continue improving global flood mapping.
Okay.
So, Nicolas, can I say something?
Okay.
I'm not sure. I think there may be confusion because Chloe is with us and we were the acronym GOF, but I'm not sure we were introduced correctly. I am not sure. Anyway, so it's the RSS Hydro team and it's a team of students that won this challenge, but I'm not sure whether there's a confusion with the introduction.
Okay,
So,
we have to check. Okay, thanks for pointing that. We have to check.
just want to make sure. Sorry.
Sure. Okay, we'll check that. Sorry for the confusion. Okay.
Well, welcome on board, RSS Hydro. Next up is the U3S lab, and then we are moving to Italy with 3 students from the University of Bologna. Is there anyone who, Alessandro?
Yeah, so good afternoon, everybody, at least for colleagues that are in Europe. So actually, we are a small team from the University of Bologna. It's me, Alessandro Lotti. I'm a PhD student in aerospace science and technology. Then we have Alfredo Loccarini, which is an adjunct professor in space system, and Riccardo Gianfelici, which is a bachelor student that graduated today. So he's not here, he's probably having a party somewhere. So basically our idea is to use the onboard processing power given by the multispectral camera in order to make a short-term prediction about the evolution of water quality parameters, so that we can assess and monitor potential hazard to the environment that before they happen. So the idea is that we can transfer to Earth just an alert without the need to, let's say, to transmit the entire hyperspectral data. And at the same time, we seek to take advantage of several images taken of the same area at different times, so we can exploit the revisit time of the ISS to make these kind of predictions. And that's pretty much all.
Great. Well, welcome on board, and congratulations to your colleague as he's partying right now. Nicolas, next one.
Yeah, the next one is is actually IRT Saint-Exupéry again. So I don't know, Adrien, if you'd like to say again some few words about maybe this idea that you are pushing for the Imaginary track. Adrien, are you nearby? Okay, if not, I suggest that.
Sorry, yeah.
Yeah, go ahead.
Okay, so yeah, I'm not sure you heard what I just said. So we start again. Just I was saying that we were very happy to have been selected on both tracks. Thank you very much. I don't have much more to say on our solution at the moment. Just I wanted to thank the whole team here at IRT. Just mentioning that it's been the work of an effort of several people here since March this year. So we're very happy that we have been selected in the end.
Sounds good. Last but not least, Anne-Catherine.
Last but not least, we also have a team of KP Labs that will be onboarded for the Imagini mission, or for the incubation phase. So KP Labs is a new space company based in Poland. They also have their own satellite, but it's really cool to see that they've participated in this challenge as well, and are really spreading their wings everywhere. I think I've seen Jakub online. Do you want to say something?
I'm not sure if you can hear me. Probably yes.
Yes.
Yeah. Yes, we are very excited to be here in the incubation phase. I think we have also Łukasz and Agata online, so perhaps a few words on our idea is to utilize hyperspectral data for monitoring and extracting soil parameters to hopefully optimize the way we fertilize and how we exploit crops worldwide. And we hope to bring enormous scalability on both the satellites using AI. So we are super excited to be here, and thank you for making this happen.
Well, welcome on board. Very happy to see you here as well, and congratulations to all of the teams that have passed the jury of the Imagini track in the OrbitalAI challenge. We wish you best of luck in your incubation phase. And with that, we want to tell you a little bit about what is going to happen next, because this is not the final step, of course. We will put you through another process of a few months. Nicolas, can you tell us a little bit more about the VSAT-2 track incubation?
Sure. So the idea is that by the end of this week, if you can change the slides, please. By the end of next week, or this week, we'll provide you some written feedback on your solution. So highlighting the good points, but also the bad points that you submitted. So we'll provide you some feedback. And then from that, obviously, we'll hope that you will be able to improve your solution. There will be a very hard requirement in the months to come to use the provided VSAT-2 simulator. There was some kind of submission for which you are not entirely compliant. You didn't use fully the simulator. But during this incubation phase, we'll ask you to really use it and validate your results and provide also all the, let's say, provide all the comments and the details that we need to really understand the data format, normalization, and stuff like that. So we'll provide you the feedback. And actually, you will have 1 month to prepare for the second round of evaluation. So during the week of the 13th of November, we'll have one-to-one session with each team. Actually, it will be a 45-minute slot, whereby you will be asked to provide, to details actually your proposal, and then we'll have 30 minutes of Q&A session. And then based on this 45 minutes discussion, we'll down select from 10 to 5 teams. We'll provide you any feedback on written, and of course, we'll be free to have a call upon request. Next slide, please. And then with these 5 selected teams, we'll introduce you towards the CONISAT board and the RUPIA system, which is the system we used and deployed by Ubotica, so that you will be able to connect to the CONISAT and deploy your software validated in the relevant hardware environment and setting. Of course, you will have all the support from Ubotica to do that. And so from end November to, let's say, mid-end January, so you will have to do this deployment, do the final validation of your solution. And then end January, we'll do the final selection and then select from 5 to 2 teams. Likely, we'll onboard as well 1 team that will act like as a backup. And later in Q1 2024, there will be a full integration of the 2 prototype into the NanoMO framework, which has been developed by CGI. So you will have the support from them so that you will fully integrate your application within the SDK made by them. So this is the journey toward the full integration and deployment. Next slide, please. In terms of schedule for flights and so on, I mean, as you know, the situation for the European launcher is a bit tricky now. We still hope that we'll be able to fly in Q1 or Q2 next year, in 2024. So there will be about 4 months for commissioning phase and calibration in phase for the payload. And then after that, so it will be then probably in Q3, Q4 2024. There will be some phase over which there will be a fine tuning for each application. So as you may remember, there are 4 applications, and then these 2 coming from the challenge. So you will be part of the pool of application, and then during this 2 to 6 months period, you will have some dedicated acquisition for you, and then you will be able to fine tune your model, and then there will be the nominal operation. I think will be more for 2025 now. So I hope it explained a little bit more the journey toward the onboarding phase and then the flying phase later this year in 2025 for the selected and winning teams. Over to you guys. And I guess this is the term for Imagine Track now.
Yeah. Thanks, Adam. Do you want to explain how it will go for the teams that are going into the Imagine incubation phase?
Certainly. Can you hear me okay?
Yeah.
Excellent. Yes, please go to the next slide. So yeah, once again, you know, each one of the awardees, thank you for all your work and for the submissions. We really enjoyed reading them and learning about your technology. And as with the FISAT track for Imagine, we have a few months of work ahead of us to integrate your solutions and understand how they're integrated into our platform. So what we intend to do here is by the end of this week, we will be distributing Microsoft Space SDK license agreements. So these are free license agreements that just need your review from your team to make sure that you understand the criteria and rules around using the software. This is the software that will be used to map your application onto the processing platform in space. Our hope by giving these to you this week is that you'll have time to review, ask questions and things, and then ultimately sign those license agreements by the end of October. Also, by the end of October, our colleagues at Thales and Microsoft here will both provide written feedback to the teams. As Nicolas said, both the good and the constructive feedback that will help improve the likelihood of success later on. Then the first week in November, we intend to do a general webinar to the 6 teams that were awarded here with some Q&A opportunities, basically to update you on the operations and any constraints that exist on the Imagine payload, so you're very familiar with how that will be operating. Also that week, we intend to, given that the agreements have been signed, access to all the Space SDK materials. After the teams have had a chance to just read through those, look at them, become familiar, we will have another open session for the different teams to walk through how to use the SDK and answer any questions at that time. Can you go to the next slide, please? So from the middle of November through to the first week of December, that will give the chance that the teams will have the opportunity to incorporate the feedback that we provided, the new information or updated information on Imagine and your updated understanding of the SDK. Provide some updates to your submission. Unlike the FISAT, we're not doing a down select at this stage or at this time. We're already in the 5-6 team range, so we're going to keep folks on beyond this, but we do want to have sort of a status update on what you've learned in the couple months and how you plan to adjust or improve your solution to meet your new understanding of or updated understanding of the SDK and the platform. Then after those one-on-ones, we will open up some support channels for the SDK. So that just means developing the SDK is something where we want you to be able to ask questions and provide feedback. And so we'll give you points of contact and ways to do that. In the mid-January timeframe, we want to finalize the final submissions here with some prototype applications written in the SDK. These don't have to be the final one, but these are your first prototype, mapping your current solution into the application framework that we have, and you'll submit those for evaluation. And then sometime in February, mid-February, we'll make that final selection of 2 teams. And as with the FISAT track, probably have one as a backup as well. So those selections will be based again on the prototype applications and what was presented in December in terms of your updated concept of operations and understanding of your solution in the context of Imagine. If you could go to the next slide, please. So we are targeting a March 2024 liftoff of the payload onto the International Space Station. After launch, there is a few month period, around 3 months, that involve the installation and then checkout of the payload on the exterior of the space station. Following that, we'll have a 12-month operational phase, minimum 12-month operational phase, and one that could be extended to at least another 12 months if we choose. And then there would be a 1-month decommissioning period after 1 or 2 years. So with the 2 or 3 teams that get moved on to the next, we will begin finalizing applications to go into orbit, providing more test beds and test points in the time between February and when we actually start operations, likely in April or May timeframe. And I think that's it. Elisa, is there anything else you want to add from Elisa from the Thales team? No, I think that's it then. Thank you very much.
Thank you, Adam, for the explanation. So I think all our teams have something very exciting to look forward to. A few more intense months, but the possibility to have your prototype on board one of the 2 missions, the FISAT-2 mission or the Imagine mission. So we've reached the end of our hour. Thank you very much already. I think to wrap it up, I'll give the floor to Nicolas.
Yeah, first of all, I like to thank all the participants. I mean, I duly acknowledge all the efforts required to participate to this challenge. I mean, this is a lot, and again, this is way beyond the standard Kaggle where you just submit a solution. I mean, here we ask much more than that. Thanks a lot for your participation. And also, I'm very sorry for the one that could not pass the next step with us. I'd like to take this opportunity to thank all the partners, industrial partners, helping on these 2 tracks. For the FISA2, I mean, as you may know, FISA2 has been implemented by Open Cosmos, and also in the back end, you have CGI helping on the coordination, especially on the application. We have also Ubotica that will help on the AI on board, demos on the data preparation, and so on. So I'd like to thank these partners. And of course, for the humanity track, I'd like to thank Microsoft and Thales for coming to us for this challenge, and also Cosine and the Italian Space Agency for helping on the data preparation and the access of Prisma. The sponsors have to be acknowledged. I really appreciate the effort of S-Rays and also Synergize to provide these sponsors and these prices. And as you may not know, this AI for AO challenge is also implemented by a set of partners in Europe. As a prime, we're a SpaceX partner, a company based in Belgium, and also with the support from Uspulse, Planetech, Synergize, and Gematic. So thanks you all guys for helping on everything. And I leave you the floor, and Catherine, go ahead.
Thank you very much, Nicolas. Thank you all for being here today, for participating in the challenge. And you will get more information about the prizes, the next steps via email. But in the meanwhile, I wish you all a pleasant evening, rest of the day, night.